am Terry Holbrook from Wakasa High School, and we're going to do a lesson on equations and inequalities for pre-calculus. The first thing we're going to do is we're going to start with the quadratic equation again, and we're going to solve by completing the square. So the first step in completing the square is to make sure the x squared coefficient is equal to 1. So I'm going to come over here and divide each term by 3, and I get x squared minus 2x minus 4 is equal to 0. The second step on completing the square then is to move the constant to the other side. So I'm going to move, I'm going to add 4 to both sides and come up with that equation. Next step is we're going to take half of the b term. The b term is the x term. Square it, and we're going to make sure to add to both sides of the equation. So if I take half of that number, I get negative 1. If I square it, I'm going to get positive 1. And the most common error is forgetting to add it to both sides of the equation. I'm now going to take the left-hand side and factor it. And you could factor it by hand. You do x and x. 1's going to be 1 and 1. It gives me a 1x and a 1x. But I wanted to add up to the negative 2x here. So both of those terms have to be negative. So if you notice, it's x minus 1 by x minus 1. And it turns out that when you factor this, when you complete the square of this down here, it always turns out to be whatever your variable is, which is and the half number. The half number was negative 1. So that is equal to 5. To get rid of the square, you're going to take the square root. Don't forget, when you take the square root of a number, there's a positive and a negative value. And last, I'm going to add over the 1. So my solutions are 1 plus or minus the square root of 5. So those are the basic steps on completing the square. So to do a little more complicated version, we have different variables and constants in here. So we're going to take this same equation, or this equation, ax squared plus bx plus c equals 0, and we're going to solve it for x just like we did the last one, but we're going to have other letters in here that are going to make it a little trickier. So the first step still was, we want the coefficient of the x squared to be 1. So I divide everything by a. I'm going to get x squared plus b over a x plus c over a is equal to 0. And then I need to move the constant. So x squared plus b over a x is equal to negative c over a. Now notice I left a space in here, because our next step was we were going to take half of that coefficient of x. So half of b over a is b over 2a, but then we're going to square it. So half of that turned out to be b over 2a squared is b squared for a squared. But don't forget, you have to add that to both sides. Then if I factor this, it's the variable, which is x, and it is the half number. And the half number was b over 2a. It'd be nice over here if we had a common denominator so I could put those two fractions together. So my common denominator would be 4a squared. And I can make this a 4a squared by multiplying both the top and the bottom by 4a, because it already has 1a there. So if I do that, I'm just going to write in the other direction. I'm going to write this one first. I have b squared, and I have a minus, a 4, and an a, and a c. Next step, I'm going to move it over here, is it's squared, so we took the square root. So x plus b over 2a is equal to, don't forget, plus or minus, because we're taking the square root. Now the top, I'm just going to write it as the square root of b squared minus 4ac, because it doesn't have a nice square root. But the bottom of this, I can take the square root of, because the square root of 4 is 2, and the square root of a squared is a. And then the last step, I'm going to subtract over the b over 2a. And at least it's very nice we have a common denominator already. So our common denominator is 2a. If I subtract over the b over 2a, I end up with negative b plus or minus the square root of b squared minus 4ac. And I hope you recognize that. That is the quadratic formula that we've been using earlier in this class. But that's how this formula was actually derived. It was actually derived by using completing the square. So there's our quadratic formula that is very, very useful in all of pre-calc and math. So here is an equation for you, or a problem for you. And it says for the years 1850 through 1990, the population of the United States can be closely approximated by this equation. Y is the population, be careful, the population's in millions, and Y is the year. X is the year. So, the first thing I'd like you to do is use the equation to estimate the US population in the year 1900. Okay, let's see how you did. So to put this in here, you would have y would equal 0.006609. We're substituting in the year 1900 squared minus 23.771. We're still substituting in the year 1900 and adding 21,382. And if you type that in and work that out, you would end up with 75.59. Now remember, Y is the population in millions, so that is million people in the U.S. in the year 1900. Now, part B is a little trickier. It wants you to go backwards now and figure out the year in which the U.S. population reached 200 million. So I'd like you to try that problem, please. Okay, for this problem, we're going to put remember Y is in millions, so we're just going to put the 200 in for Y, not the 200 million. We are looking at right now that we're going to try to solve for x. And we're going to use the quadratic formula, but to use the quadratic formula, your equation has to be equal to 0. So I need to subtract over the 200, and then I'm ready to begin. So if I use this is my A term, that is my B, and that is my C. And if you work that out in your quadratic formula, you actually will end up with two answers. And the answers are the year 1969 and the year 1628. Now, do you really think the population in the year 1628 was 200 million people? So if we have to go back, this is our domain. This equation only works for the years 1850 through 1990. So this solution we need to remove because it's not in our domain. So the year we are looking for here is the year 1969. So here, consider the quadratic equation x squared equals 5 minus 3x. I'd like you to use the quadratic formula to find the roots of that equation. And after you do that, could you find the product of those two roots and the sum of those two roots? Okay, so before we can do this equation in the quadratic formula, we need to make it equal to 0. So I'm going to add over the 3x and subtract the 5. Then I know my a is 1, my b is 3, and c is negative 5. So using the quadratic formula, x equals negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times a times c is a negative 20. So that's going to make that actually a positive value in there, a plus plus, all over 2 times a, which is 2. So we're going to end up with the answer or solutions, negative 3 plus or minus the square root of 29 all over 2. Okay. So now, the product of these roots. So what I'm going to need to do is take negative 3 plus the square root of 29 over 2 and multiply that by negative 3 minus the square root of 29 over 2. So I'll go to the denominator first just because that's easier. So the 2 times the 2 does give me 4. Now multiplying the tops of those two fractions, the numerators, could be a little tricky. So I'm going to draw my box, and I'm multiplying negative 3 plus the square root of 29 by negative 3 minus the square root of 29. Okay. These are actually called conjugates, and the nice thing happens when you multiply conjugates. The negative 3 times the negative 3 is 9. That would give me negative 3 times the square root of 29. This box is 3 positive 3 square root of 29. And here I'm going to get a negative. I have a negative times a positive. And square root of 29 times square root of 29 is 29.